Welcome back to our Chem 152 video series. In this video, we'll talk about how to find the pH and the pOH of strong acids and bases. We'll begin with a strong acid example. The question says, if you have a 0.50 molarity solution of HCl, what are the pH and pOH? Now, if you do have a strong acid, there is an equation to find the pH first. We can say that our pH is equal to negative log of the concentration of the strong acid. We usually abbreviate the concentration of strong acid as bracket H3O plus. This H3O plus can stand for any strong acid. I want to point out before we go any further that this equation is only good for strong acids. Weak acids take quite a bit more math to find their pH. This equation by itself will not be enough. We will go over how to find the pH for a weak acid in a future video. However, for a strong acid, we can just say that the pH is equal to negative log of whatever molarity we were given for our strong acid. Therefore, HCl, being a strong acid, can be used in this equation, and we'll place the 0.50 molarity inside the parentheses. With this, you can go into a calculator and find the pH. Our answer will be 0.301 for our pH. Now, in order to get pOH, we can always say that the pOH is equal to 14 minus the pH itself. If you prefer, you may also rewrite this as 14 plus log of H3O. However, since we already have the pH from our previous step, we'll just use the first version of this equation and find the pOH. We'll say the pOH is equal to 14 minus 0.301. We'll end up with 13.699 for our pOH. And so this is how we find the pH and pOH of a strong acid. If we have a strong base instead, we can use the molarity of that strong base to help us find the pOH first. If you're trying to find the pOH first, we can say that pOH is equal to negative log of the concentration of OH. Now be careful here. We have 0.5 molarity, but notice that the compound that we're looking at, our strong base, BaOH2, has two pieces of OH. For that reason, we will say that OH negative is going to be 2 times the molarity that was given to us, because each molecule of BaOH2 would supply us with 2 pieces of OH, and 2 times 0.50 molarity gives us exactly 1 molarity. This 1 molarity is what we will place in the bracket OH position. We will say that pOH is equal to negative log of 1. That 1 molarity is what goes in for the OH, and if we put negative log of 1, we'll end up with a pOH of exactly 0. Now that we know the pOH, we can find the pH based on that. We can say that pH is equal to 14 minus the pOH. If you prefer, you can also say 14 plus log of OH. Since we already know the pOH, we'll place that in the pOH position in this equation. We'll say pH is equal to 14 minus 0, which of course gives us 14. And now we know the pH and the pOH of this solution. In our last 2 examples, we started with concentrations and found pH and pOH. You may also be given a pH and be asked to find both the H3O and the OH minus concentrations. If you know the pH and you want to go the other way from what we did previously, there is another equation that will help us get H3O. You can use the equation H3O plus is equal to 10 raised to the negative pH. Since we know that our pH is 3, we can place the 3 in that position, and we will get 1 times 10 to the negative third molarity of H3O. Now, if we know the molarity of H3O, we can also get OH based on that. What we'll say is that K water is equal to H3O times OH minus. For the purposes of Chem 152, we usually let K water equal 1 times 10 to the negative 14th power. If you forget this, you can always look up this constant. It will be almost always the same number at room temperature. Sometimes the literature will add additional significant figures, but your calculations will generally be close enough to correct if you just say 1 times 10 to the negative 14. Therefore, we know what K water is, and from the previous step, we know what H3O is. We check those two off and note that our unknown here is OH minus. Therefore, we'll do a little bit of algebra and divide both sides by H3O. The H3O's on the right side cancel out, and now our equation will be OH minus equals K water divided by H3O. Our K water was 1 times 10 to the negative 14th, and then our H3O that we found previously was 1 times 10 to the negative third. If we divide, we'll end up with an OH minus concentration of 1 times 10 to the negative 11th molarity. So using this K water equation that we did, if you know the H3O, you can find the OH. And if you know the OH, you can find the H3O just by doing the algebra. Thank you for watching, and we'll see you again soon.